Hello students, in this video we are going to discuss probabilities with standard card deck. So we are going to discuss about the card deck first. The card deck has 4 categories: spades, hearts, diamonds and clubs. Hearts and diamonds are red and spades and clubs are black. You have 52 total cards in the standard card deck. Each of these 4 categories has 13 cards. Among that 13 cards, first one is ace, 9 cards are number cards and 3 cards are face cards. Then for the total card deck, there are 3 into 4 face cards, that is 12, and 4 ace cards and 36 number cards. Okay. Let's move into a question. What is the probability of drawing a king from a deck of cards? King is a face card, right? And look at this one. How many kings are there? For the face cards, one is jack, the next one is queen, and the third face card is the king. For each spade, heart, diamond and club, it has their own jack, queen and king. So there are only 4 kings for the total deck of cards, right? These 4 are the kings, right? So 4 king cards. Now, if we consider that the event A is drawing a king card, now probability of A is equals to NA divided by NS. Okay. Now, how many number of elements are there in the event A? Only 4. Why 4? Why we got 4? Because we have only 4 king cards for the total standard card deck. So 4 divided by NS, the size of the sample. Size of the sample is the number of cards in the standard card deck. So it is 52. So the answer for this one is 1 divided by 30. Let's look at another question. It's easy when you understand the standard card deck. Okay. Now the next question. What is the probability of drawing a black card from a pack of cards? Okay. How many number of black cards are there, please? These 2 sets, clubs and spades, are black. Clubs has its 13 cards and spade has another 13 of cards. Then 26 of total black cards. Okay. Also red cards are also 26, right? Now, if the event B is drawing a black card, then the probability of B is equal to NB divided by NS. How many black cards are there? 26 and 52 number of total cards, then half, or the 0.5 is the answer for this question. The probability of drawing a black card is 0.5. Even this is similar for drawing a red card. Why? We have the similar number of red cards in the standard card deck. Okay, let's move into the next part. There's a question, but before doing that one, we should understand about the addition rule in probability. Okay, this is the addition rule in probability. Probability A, O, B. You know that O we are denoting like union is equal to probability of A plus probability of B minus probability of A and B. The and we can denote like intersection, right? If we update the addition rule, A O B is equals to probability of PA plus probability of PB minus probability of A and B. Okay. What is the meaning of PAOB? PAOB means total probability of PAPB, right? And PA is the probability of event A, probability of event B is the probability of PB, and probability of A and B is the common probability happening both together. The probability of happening both A and B events together. Okay. Do you know that there are different events like mutually exclusive events and non-mutually exclusive events? Mutually exclusive events do not have a common area or an intersection area. That means they are not overlapped. This is a Venn diagram. So event A and B has no any common elements. Those are called mutually exclusive events. So for this one, probability of A and B is equals to 0, right? Because there is no any intersection area. Therefore, if you can update the addition rule for mutually exclusive events, it is PAOB is equals to PA plus PB. That is only because this term becomes 0. Okay, that is for mutually exclusive events. What happens for non-mutually exclusive events? Nothing happens. The original equation for the addition rule we can use because there is an intersection. So we cannot eliminate this one like we did for the mutually exclusive events. So there is a value for this term for non-mutually exclusive events. Okay, let's move into the question now. What's the probability of drawing either a queen or, look at this word, or, a heart from deck of cards? First, you should understand what are the two events in this question. Okay, you see that drawing either a queen or a heart. Now, event A, let's consider event A as drawing a queen. Event B as drawing a heart. Now, first of all, tell me what is the probability of A drawing a queen? You know that this probability of A is equal to NA divided by NS. Now, how many number of queens are available in the standard card deck? 4. And the total number of cards are 52. And drawing a heart means heart card. So, how many number of heart cards are there in a standard card deck? Yes, just 13, right? Then the total number of cards 52. But you know that heart card set also has one queen, right? And it is included in this queen set also. So that's why it is common. Now this has an intersection. What is the intersection? The heart queen card, right? Heart queen card is common for drawing a queen or drawing a heart. Understand? So probability of A and B is equals to 1 divided by 52, right? There is only one card belongs to both A and B events. Think that this is A event and this is B event. So what we need to do, just substitute the values we got using the Venn diagram to find out the answer for this question. Probability of A or B. Just you can write down probability queen or heart, whatever the possible way you can use. And now for this one, addition rule is PA is how much? We got 4 out of 52 plus probability of drawing a heart card is 13 out of 52 and reduce the common heart and queen, right? That is 1 out of 52. So the value for this one is 16 out of 52, which is 4 divided by 13. It's easy, right? And what you have to do is, please just understand the concept and imagine the cards, and even you can draw whatever the possible way use, and keep that the addition rule in your mind, and make sure that you use proper addition rule when it comes to mutually exclusive events and non-mutually exclusive events where you can see an intersection. Okay, thank you very much, and let's meet with another video. Subscribe me for more videos. Thank you.